Hello my friends, and welcome back to the You Can Do TV channel. Plywood machinery plays a pivotal role in the production of plywood, a versatile and widely used building material. These machines are designed to efficiently process logs and produce thin layers of wood veneer that are then glued together to create plywood sheets. Among the key machines in this industry is the Spindle plywood veneer peeling machine, which is a crucial component of the plywood manufacturing process. The Spindle plywood veneer peeling machine is a remarkable piece of equipment that automates the process of peeling logs into thin veneer sheets. Here's how it works. Log preparation. Before the logs are fed into the machine, they undergo a preparation phase where their bark and irregularities are removed. This ensures a smooth and uniform peeling process. Feeding and clamping. The prepared logs are then loaded onto the machine. The Spindle plywood veneer peeling machine typically consists of a rotating spindle that holds the log in place. The log is securely clamped onto this spindle to prevent any movement during the peeling process. Rotating and peeling. Once the log is in position, the spindle starts rotating. As it rotates, a sharp cutting blade or knife peels off thin layers of wood from the log. The thickness of these veneer sheets can be adjusted based on the machine settings. Continuous feeding. The machine is designed for continuous operation. As one log is being peeled, another can be loaded onto the machine, ensuring a consistent output of veneer sheets. Veneer collection. The peeled veneer sheets are collected as they come off the log. They are then stacked or sent to the next stage of the plywood manufacturing process, which may include drying and gluing. Quality control. Modern Spindle plywood veneer peeling machines are equipped with sensors and quality control mechanisms to ensure that the veneer sheets meet the desired thickness and quality standards. Any defects or irregularities can be identified and corrected during this process. In addition to the Spindle plywood veneer peeling machine, plywood production lines often include other equipment like veneer cutting machines, dryers, and stackers. These machines contribute to the efficient processing of veneer sheets and the production of high-quality plywood. Plywood machinery has revolutionized the woodworking industry by significantly increasing production efficiency and reducing manual labor. It allows manufacturers to produce plywood sheets of consistent quality and thickness, which are essential for various construction and manufacturing applications. Moreover, with advancements in automation and technology, these machines continue to evolve, further enhancing their precision and output capacity. Here's a detailed look into the production process of ARAUCO's plywood mills at ARAUCO in Wavell. Log yard and conditioning. The process begins in the log yard, where a continuous watering system maintains the humidity of already debarked logs, preventing their degradation. These logs are then placed in conditioning chambers and soaked in hot water at 85 degrees Celsius for 18 hours. This enhances the wood's plasticity. Peeling process. Once conditioned, the logs undergo a peeling process, transforming them into long veneer ribbons. An advanced scanning system identifies and clips away any defects. These veneer ribbons are then sliced into sheets of varying sizes, depending on requirements, and are sorted based on their moisture content. Drying. The veneer sheets then proceed to the drying process, where excess moisture is eradicated. The drying machinery, equipped with a roller system and a jet box system, ensures an even moisture distribution throughout the veneer. Grading and sorting. Post-drying, the veneer sheets are visually inspected, graded, and sorted. They are then stacked and left for at least 24 hours for moisture content equalization. Composing and patching. Some veneers are sent directly to the panel layup station, while others undergo composing or patching processes. The composer handles veneers with defects, turning them into crossband veneers. At Wavell's mill, an automated system powered by robots repairs veneers by removing defects and inserting wooden patches. Gluing process. At both mills, there are two types of glue application methods, a roller glue spreader and an automatic liquid extruder. Depending on the method, veneers are manually laid up with glue or automatically glued. Pressing. Panels undergo a cold pressing process first, which aids in glue line strength development. Subsequently, each panel is sent through a hot press to cure the adhesive using heat and pressure. Panel repairing. An automated panel repairing line identifies surface defects. If the defects don't meet the grade specifications, they are rectified using either water-based putty or polyurethane. Any remaining defects are manually addressed. Trimming and sanding. Panels are trimmed to remove uneven edges and given their final format. They then go through a sanding process to ensure a smooth surface finish and thickness calibration. Grading. Every board is meticulously graded for both its face and back based on customer requirements and international standards. Grooving line. To further add value, the boards can be sent to a grooving line where they get different edge profiles and surface textures. Packaging and delivery. Finally, the finished plywood units are packaged and stored. A wood debarker machine, also known as a wood peeler, is a crucial piece of equipment in various industries involved in wood processing, such as paper mills, veneer rotary cut factories, and wood factories. It plays a significant role in efficiently removing the bark from logs and timber, preparing them for further processing. Let's delve into the details of how a wood debarker machine works and its key features and advantages. Working principle. The primary function of a wood debarker is to strip the bark from logs or timber. This process is vital for several reasons, including improving the quality of wood products, enhancing production efficiency, and reducing the risk of damage to cutting and processing equipment downstream. Here's how a wood debarker machine typically operates. Feeding. Logs or timber are fed into the machine using a conveyor system. The feeding mechanism often employs variable speed drives, allowing it to handle various types of wood, including frozen wood, bending wood, and different wood species like eucalyptus and oak. Debarking. Once the wood enters the machine, it encounters a set of rotating blades. Most modern wood debarkers use four-bladed cutters, which are efficient and cost-effective. These blades are designed to peel off the bark layer from the wood's surface. Hydraulic control. The pressure exerted by the cutter blades on the wood is controlled hydraulically. This hydraulic control system ensures that the debarking process is precise and adaptable to different wood types and conditions. The advanced hydraulic structure contributes to the machine's reliable performance. Peeling clarity. The wood debarker machine is designed to achieve a high peeling clarity rate. This means that it removes the bark efficiently while minimizing damage to the underlying wood. High peeling clarity is essential for producing quality wood products. Output. After passing through the debarking process, the wood emerges without its bark. The machine is equipped with mechanisms to ensure that the debarked wood is automatically ejected or sent out for further processing. Key features: four-bladed cutter. The use of a four-bladed cutter makes the machine easy to use and cost-effective, ensuring efficient debarking. Hydraulic control. The hydraulic control system allows for precise pressure regulation, ensuring the machine's reliability and adaptability to various wood types. Variable speed drives. The variable speed drive mechanism enhances the machine's ability to handle challenging wood types, including frozen wood, bending wood, and different wood species. High peeling clarity. The machine is designed to achieve a high peeling clarity rate, ensuring that the wood is efficiently debarked with minimal damage. Advantages. Automation. The wood debarker machine automates the debarking process, reducing the need for manual labor and increasing efficiency. High yield. A well-maintained wood debarker can achieve a bark removal rate of up to 95%, ensuring that a significant portion of the wood's surface is clear of bark. Versatility. This machine is versatile and suitable for various wood types, including fresh-cut softwood, broadleaf trees, frozen wood, and dry wood. Adjustability. Depending on the specific wood type and condition, the peeling effect can be adjusted to achieve optimal results. The manufacturing process of ARAUCO Particleboard and Prism TFL panels begins with the collection of 100% recycled and/or recovered wood chips and shavings. Trucks transport these wood materials to the manufacturing facility. Upon arrival, the wood chips are unloaded and stored in collecting areas. They are then loaded onto a conveyor system and deposited into storage silos. In this stage, the surface and core materials are separated and refined using a series of shakers, conditioners, and filters to eliminate contaminants. Quality control checks are performed throughout this process to ensure the wood materials meet the required specifications in terms of particle size, humidity levels, and decontamination. The wood chips and shavings are sent to drying units to reduce moisture content. Core material is dried to around 2 to 3% moisture content, while surface material is dried to approximately 6 to 7%. In the blending area, the dried wood materials are combined with resin and other additives. Different types of resins may be used to create specialty particleboard, such as moisture-resistant or fire-rated products. The blended material is then fed into a massive continuous press. Multiple layers of wood material are stacked according to product specifications and pressed together using a combination of heat and pressure. This process allows for precise control of variables like particle geometry, resin levels, and board densities. After pressing, the boards are cooled and cut to the desired product dimensions. Large rotating racks facilitate the cooling process. Samples of the formed boards are regularly taken to the Quality Assurance Lab for a series of tests to ensure strength, density, and other key specifications meet the required standards. TFL production. Prism TFL panels. Some finished boards continue to the thermally fused laminate TFL production line to create Prism TFL panels. These panels are equipped with a wide range of decorative overlays, including solid colors, abstract designs, and wood grain patterns. These overlays are saturated with melamine and other resins for adhesion, strength, durability, and resistance to UV and chemicals. Lamination. The treated decorative sheets are carefully placed on the boards and laminated with high temperature and pressure. During this process, the overlay is thermally bonded to the board, and texture impressions and gloss levels are infused into the surface using steel plates. Final stages. In the final stages of particleboard production, the boards are stacked, packaged, and stored in the warehouse. They are then loaded onto trucks for delivery to customers. These panels find applications in cabinets, furniture, fixtures, laminates, and more. The Bandit Model 3680 Beast Recycler is a powerful and versatile machine designed to handle a wide range of wood and plastic recycling tasks. One of its key features is the optional whole tree chipper drum, which allows it to combine the productivity of a horizontal grinder with the raw chipping power of a Bandit whole tree chipper. In this article, we will explore the working principles and advantages of the Bandit Model 3680 Beast Recycler with the chipping drum option. Drum installation and retrofit. The integration of the chipping drum into the Beast Recycler is a relatively straightforward process. It involves replacing the standard cutter mold with a custom chipping drum and adding a specially designed stationary anvil spacer to the infeed. There are multiple chipping drum options available, including the 5/10 knife, 4/8 knife, and 20 knife drums. These drums can be configured to run with all knives or with half of the knife pockets blocked off to achieve specific chip sizes. The downward cutter mold advantage. One of the standout features of the Bandit Model 3680 Beast Recycler is its patented downturning cutter mold. Unlike most horizontal grinders that turn upward, this design allows the Beast to cut against a one-piece infeed chain, which acts as a moving anvil. When equipped with a chipping drum, the Beast cuts against a replaceable stationary anvil insert located at the infeed's end. This setup ensures a higher quality chip by preventing material from turning or rolling, resulting in a superior end product. Superior infeed chain. Bandit's one-piece infeed chain is another crucial element in ensuring high chip quality. This heavy-duty construction continually advances material into the feed wheel yoke and the chipping drum, providing more effective and reliable operation compared to chains used in other grinders. This mechanism contributes to delivering a superior end product. Six-speed feed system. The Beast Recycler is equipped with a 6-speed feed system that allows operators to match the conveyor speed to the desired material size. This feature prevents material from pushing against the chipping drum, which can lead to reduced horsepower and fuel economy. It also ensures that material reaches the drum at the right speed, minimizing the creation of splinters and fines. Operators can fine-tune the system to produce the correct sized material on the first pass. Massive infeed width. The Model 3680 Beast Recycler boasts a 60-inch wide infeed, providing ample space for spreading out material evenly along the infeed chain. This feature enables the machine to handle large and wide trees, including logs, chunk wood, stumps, and regrind mulch, with ease. Versatility beyond wood. While the Beast Recycler is known for its wood processing capabilities, it also excels at handling plastic materials, such as heavy-walled plastic pipe. With the 20-knife option, the machine can produce uniform and perfectly sized plastic chips that meet the requirements of plastic recyclers. Swap between drum and cutter mill. One of the significant advantages of the Beast Recycler with a chipping drum is its flexibility. Operators can easily swap the chipping drum for the traditional cutter mill and vice versa. This means you can choose the appropriate hardware for processing a wide range of materials, from chunk wood to branches and logging slash. Adapting to changing markets. The Beast Recycler can adapt to evolving market demands thanks to its ability to switch between processing modes. This versatility ensures that it remains a valuable asset for businesses in the recycling industry, regardless of market fluctuations. Expert support with Bandit Backbone. Bandit stands by its products, offering free expert support through its Bandit Backbone program. This ensures that customers have access to assistance and guidance whenever needed, enhancing the overall ownership experience of the Beast Recycler. Eagle Valley Wood Pellets is a leading producer of premium quality wood pellet products dedicated to turning raw wood waste materials into an environmentally friendly and efficient energy source. Their manufacturing process begins with the collection of wet biomass materials from various sources, including sawdust and wood shavings, which often contain around 40% moisture. These raw materials are delivered to Eagle Valley's production facilities in Princeton and West Bank, British Columbia. To prepare the raw wood waste for pellet production, it goes through a hammer mill, which reduces it to a finer wood fiber. This step facilitates drying and further processing. The moisture content is then reduced to around 6 to 9% in a drying process. Notably, Eagle Valley utilizes a biomass burner that is powered by production fines, reinforcing their commitment to sustainability. The prepared wood fiber material is then fed into a pellet mill, a massive steel die extrusion wheel with thousands of holes and rollers that force the fibers into these holes under tremendous pressure. This process forms the wood pellets, which are later cooled and double-screened to remove any fines and dust, ensuring uniformity in pellet quality. With the final production processes completed, the wood pellets are ready for bulk shipping or packaging. The finished pellets are either loaded into containers or transported to regional, continental, or international destinations. Eagle Valley's proximity to the Port of Vancouver gives them a logistical advantage in serving global markets. Wood pellets produced by Eagle Valley offer an eco-friendly solution for residential and commercial heating, as well as industrial energy needs. This is the PM200 pellet mill, meticulously crafted in Germany to meet the demands of efficient pellet production. This cutting-edge machine features a capacious mixing container designed to accommodate a wide range of pelletizable materials, including wood chips. The PM200 boasts a versatile dosing screw, allowing for precise adjustment of material flow rates. To enhance its capabilities, this pellet mill incorporates a high-performance water pump seamlessly integrated, capable of adding 0 to 5 liters of water per hour to the mixing process. Operational efficiency is key, as raw material is introduced via the hopper and transformed into pellets through a controlled process of pressure and temperature elevation. Notably, the quality of the resulting pellets is profoundly influenced by the moisture content, typically around 15%. It's paramount to ensure the material is free from contaminants such as stones or metal, underlining the need for preliminary processing with a hammer mill for optimal results. The PM200 pellet mill represents a pinnacle of German engineering, offering precision, adaptability, and reliability for a variety of pellet production needs. The grass pellet mill offers a convenient gateway for individuals to embark on the journey of grass pellet production right in the comfort of their homes. In recent years, pelleted fuels have surged in popularity owing to their clean, low-emission, highly efficient, and easily transportable and storable nature, with wood pellets fueling this trend. These versatile pelleted fuels find application in a wide array of settings, from stoves, household furnaces, and outdoor hydronic water heaters to large-scale power plants. Grass pellets, in particular, share the same energy content as wood pellets, but do tend to produce more ash when burned in home stoves, potentially leading to ash residue issues. Fortunately, research suggests that blending 20% wood pellets with grass pellets can effectively resolve this concern. Producing fuel pellets from grass comes at a lower cost compared to wood pellet production, making it an economically attractive choice. Moreover, the global acceptance of grass-based biofuel pellet production makes it a well-established and sustainable technology. Utilizing grass pellets as a source of fuel material emerges as an energy-efficient, eco-friendly, and economically viable solution, aligning perfectly with sustainability goals. The Model P pellet stove is a remarkable heating solution that operates without the need for electricity. These stoves rely solely on gravity to feed wood pellets into the combustion chamber, making them incredibly efficient and environmentally friendly. The pellets used in this stove can be made from various biomass materials such as paper, cardboard, wood, or grass, which are mechanically compressed into fuel pellets through a process called compaction. One significant advantage of this fuel source is its sustainability and eco-friendliness. These pellets have a high energy content, ranging from 4,000 to 5,000 kilocalories, and they offer precise control over the heating process. The Model P can burn 20 kilograms of pellets per hour, making it both cost-effective and easy to handle. The stove features a steel structure with a temperature control system and a hopper for pellet storage, Reflectors are designed to maximize heat distribution, ensuring efficient warmth throughout the room. With just a single daily load into the hopper, the Model P can provide heating for 20 to 36 hours, making it a convenient and reliable choice for environmentally conscious homeowners. The Puro WIN wood chip boiler represents a groundbreaking innovation in the world of biomass heating systems. Developed by Windhager, this cutting-edge appliance incorporates their patented updraft gasification combustion chamber, making it the cleanest wood chip boiler in the world. The key principle behind the Puro's exceptional performance is harnessing the natural filtering effect of wood chips. Windhager's intensive research and development efforts have redefined the wood chip boiler industry, setting revolutionary standards. One of the most remarkable features of the Puro WIN is its ability to achieve incredibly low dust emissions that are nearly undetectable. This is achieved through a meticulously designed combustion process. The entire combustion chamber of the Puro WIN is constructed from high-quality stainless steel, ensuring both robustness and safety. The boiler employs a smart fuel detection system to continuously transport the correct amount of wood chips into the combustion chamber via the stoker auger. This ensures an efficient and controlled burning process. The combustion process in the boiler begins with filling the complete chamber with wood chips. A supply of primary air and a single ignition process create an ember bed in the bottom section of the chamber. This ember bed carbonizes the wood chips above it, essentially forming an active carbon filter. Fine dust particles are filtered and retained within this charcoal layer. The combustible wood gases rise from the ember bed through the layer of carbon and unburnt wood chips. Once outside this layer, these gases are enriched with additional air and ignited by an energy-saving glow igniter. This innovative design ensures that combustion always occurs above the layer of wood chips. One of the standout features of the boiler is its wood chip gasification system, which produces emissions so low they are nearly immeasurable. The boiler's sealed design allows the ember bed to remain active for up to 4 days without the need for additional fuel or combustion air. This not only conserves energy, but also significantly reduces the need for ignition, cutting ignition energy costs by up to 90% compared to competitor wood chip boilers. The Puro WIN also incorporates a unique ash removal system. Patented twin ash removal plates allow for ash removal without shutting down the boiler. This is a major advantage as it ensures continuous operation. The ember bed slide and ash removal plates work together to prevent foreign bodies from interfering with the combustion process. In the production of wooden shingles, the journey from a tall, robust spruce tree to finely crafted shingles begins with a meticulous process. This process begins peeling the bark and then carefully sawing the long log into shorter, more manageable pieces. These pieces are the raw materials from which we fashion the shingles that will grace roofs and walls, enhancing the character and durability of structures. Peeling the bark manually is a labor-intensive task that demands patience and precision. It is a crucial step in preparing the wood for shingle production. The removal of the bark not only reveals the pristine wood beneath, but also ensures that the shingles will have a smooth and uniform surface. Following the bark removal, the long log is then carefully sawn into shorter pieces. This step requires the skill of an experienced craftsman who knows just how to make the precise cuts to create the optimal dimensions for the shingles. Each cut is a deliberate move towards transforming the raw wood into a functional and aesthetically pleasing building material. One crucial consideration is the timing of the wood's harvest. The spruce wood used for shingle production should ideally be felled in December, specifically during the last quarter of the waning moon. This timing is believed to yield the highest quality wood for shingles. It is a testament to the intricate balance between tradition and nature's rhythms that defines the art of wooden shingle production. The log is typically placed horizontally on a sturdy support structure, such as a splitting block or log holder. This positioning ensures stability during the splitting process. A reference line is carefully marked along the length of the log. This line acts as a guide, ensuring that the log will split into uniform sections. The woodworker employs wedges to initiate the splitting process. These wedges can be wooden or metal and are driven into the log along the marked line. Precision is essential to ensure a clean and even split. The woodworker exerts force on the wedges, causing them to penetrate the log's fibers. As the pressure increases, the log begins to split along the predetermined path. Successful hand splitting requires a delicate balance between force and precision. The woodworker must navigate this fine line to achieve an even and accurate split. Depending on the desired dimensions of the shingles and the log size, the splitting process may be repeated several times. Each split results in large sections that will later be further refined into shingle blanks. To prevent warping and splitting as wood dries, it's essential to cut both shakes and shingles from the edge grain. Careful consideration of the wood grain orientation is crucial when splitting blocks and crafting shakes or shingles. Similarly, during bucking, precision is vital to ensure cuts align precisely perpendicular to the grain, minimizing waste and upholding product quality. For effective bucking, thorough clearing of the log is necessary to achieve a clear view of the grain, facilitating straight cuts perpendicular to the grain. In the splitting process, the ringers are typically separated from the bark to the heartwood, following a perpendicular path to the grain. The removal of heartwood involves splitting parallel to the grain, while simultaneously eliminating bark, sapwood, and any imperfections like rot or bug holes. The initial split always targets a knot, burl, check, or other imperfection to maximize block size while disposing of waste. Blocks should never be split in areas of clear wood, as this can result in imperfections within the block or necessitate excessively small splits when flaws are removed. When dealing with large logs or highly twisted pieces, there is often a need to cant or divide the entire log into slabs. This process involves the removal of a ringer at each end of the tree to expose the log's interior. Wedges are then inserted into the face to initiate the split, typically targeting a natural check or imperfection that extends the log's full length. As the face begins to separate, wedges are progressively driven into the resulting gap, starting from near the face and gradually advancing toward the log's opposite end in incremental steps. When dealing with large logs or highly twisted pieces, there is often a need to cant or divide the entire log into slabs. This process involves the removal of a ringer at each end of the tree to expose the log's interior. Wedges are then inserted into the face to initiate the split, typically targeting a natural check or imperfection that extends the log's full length. As the face begins to separate, wedges are progressively driven into the resulting gap, starting from near the face and gradually advancing toward the log's opposite end in incremental steps. Central to the success of the hand-splitting process is the experience and expertise of the woodworker. These skilled craftsmen possess an intimate understanding of wood's unique characteristics, including its grain patterns and natural tendencies during splitting. This knowledge empowers them to make informed decisions and adjustments throughout the process, ensuring the best possible outcomes. Shake blocks undergo a process where they are split into 1-inch thick, 25 mm slats, known as blanks. This division is achieved using one of two methods: a hydraulic press, equipped with a blade, referred to as a cuber, or manual splitting employing a froe and mallet. When the blanks are derived from the same edge of the block without flipping it, they maintain a consistent thickness throughout. Alternatively, the splitter may opt to flip the block after each blank is removed from its edge, resulting in a tapered split extending from one end to the other, commonly referred to as tapers or hand split. Blanks that lack this natural taper require additional processing before they can be used. They are fed through a large band saw, manually guided to cut them diagonally from corner to corner, thus forming a tapered shake with one sawn face. For the production of shingles, circular saws with typically 42 to 48 inches, 1.1 to 1.2 meters in diameter, are employed to cut them from the blocks. The blocks are securely held in a carriage that moves back and forth along the blade, tilting and advancing the block closer to the blade with each pass. This automated process ensures the formation of a tapered cut with the correct thickness. Subsequently, the shingle edges undergo further refinement through the use of another circular saw, referred to as a trim saw. which is responsible for eliminating irregular edges. The outcome is a tapered shingle meticulously cut on all 6 sides. The thickness of the butt, or the thicker end of the tapered cut, typically measures 3/8 inch, 9.5 millimeters, but is also frequently produced at a thickness of 5/8 inch, 16 millimeters, and can be customized to meet specific requirements. The next crucial step in the shingle making process involves the careful drying of the freshly split shingles. This critical phase typically spans a period of approximately 2 weeks, although the exact duration is influenced by the prevailing weather conditions. Naturally, warmer weather expedites the drying process, allowing for a faster turnaround. During this period of air drying, the shingles are exposed to the elements, benefiting from the gentle caress of the sun and the natural flow of air. This process helps to remove residual moisture, ensuring that the shingles attain the ideal moisture content for their intended use. Adequate drying is essential to prevent issues like warping or mold growth later on. Once the shingles have reached the desired level of dryness, they are meticulously bundled into groups of 25 each. This bundling not only aids in convenient handling, but also provides an organized approach to inventory management. The bundled shingles are then thoughtfully arranged on pallets, optimizing storage space and facilitating efficient transportation. This careful attention to the drying and bundling of shingles underscores the commitment to producing high-quality roofing materials. It ensures that the shingles are well prepared for their eventual installation on roofs, where they will provide both protection and aesthetic appeal for years to come. In the past, traditional wooden shingles were typically slender, measuring between 3/8 to 3/4 of an inch, 10 to 19 millimeters in thickness, relatively narrow, ranging from 3 to 8 inches, 76 to 203 millimeters in width, and exhibited varying lengths of 14 to 36 inches, 360 to 910 millimeters. These shingles were almost invariably planed or carefully smoothed. The age-old method of crafting wooden shingles prior to the 19th century involved riving or hand-splitting them from sections of logs with straight grain and no knots, which had been pre-cut to the desired length, known as bolts. These bolts were then quartered or split into wedges, and thin pieces of wood were skillfully split or riven using a mallet and a froe or an axe. The choice of wood species depended on the local availability of timber, but typically only the more durable heartwood from the inner section of the log was utilized, while the softer sapwood was usually avoided due to its tendency to deteriorate quickly. Since hand-split shingles exhibited some irregularities along the split surface, it was necessary to dress or plane them using tools like a draw knife or draw shave to ensure an even fit on the roof. This dressing process was essential to create a tight-fitting roof, especially when laid over open shingle lath or sheathing boards. Dressing or smoothing of shingles was a near-universal practice, regardless of the type of wood used or the geographical location of the building, except in cases where a temporary or highly functional roof was acceptable. The fabrication of shingles underwent a significant transformation in the early 19th century with the advent of steam-powered sawmills. Shingle mills revolutionized the production of shingles by enabling the mass production of uniform shingles. These sawn shingles featured a consistent taper and smooth surface, eliminating the need for hand dressing. Consequently, the supply of wooden shingles was no longer constrained by local factors. These changes in shingle production coincided with and contributed to the popularity of architectural styles such as Carpenter Gothic, Queen Anne, and shingle-style architecture, all of which effectively utilized shingles. Despite the introduction of machine-sawn shingles, hand-split shingles continued to see use in many regions. In some areas, alternative roofing materials gained popularity, particularly in locations where slate was abundant, resulting in fewer wooden shingle roofs. Certain western boom towns favored sheet metal due to its lightweight and ease of shipping. Ornate buildings in cities with strict fire regulations often adopted materials like slate, turnplate, and clay tile to reduce fire risk. However, wooden shingles were never completely abandoned, and even in the 20th century, architectural styles such as Colonial Revival and Tudor Revival embraced their enduring appeal. Land and right-of-way clearing operations are often faced with the challenge of finding equipment that is both powerful and dependable. In this context, the Bandit Model 5000 stands out as a beacon of reliability and efficiency. As the largest stump grinder and forestry mower produced by Bandit Industries, the Model 5000 is specifically designed to withstand the rugged conditions that land clearing contractors frequently encounter. Its robust design and advanced features make it a formidable tool, surpassing all others in its class. One of the standout features of the Model 5000, especially the 5000 T-Track carrier variant, is its adaptability. Like other Bandit track carriers, the Model 5000 T can be equipped with either a forestry mulcher attachment or a stump grinding head. This flexibility ensures that contractors can switch between tasks with ease, adapting to the demands of the job site. The process of switching between these attachments is straightforward, taking mere minutes in the field, ensuring minimal downtime. The stump grinding attachment of the Model 5000T boasts a 40-inch diameter cutter wheel, which uses buck-style teeth. This design ensures aggressive grinding action, making short work of even the most stubborn stumps. On the other hand, the mulcher attachment is a testament to Bandit's commitment to quality and innovation. With carbide cutting teeth and a design reminiscent of Bandit chipper drums and Beast cutter mills, this attachment can easily cut through large trees and brush. Moreover, it is exceptionally tolerant to dirt and rocks, allowing operators to mow material and then mulch it directly into the soil. The Model 5000T doesn't just excel in performance, it also prioritizes the comfort and safety of its operators. The deluxe operator cabs are a blend of luxury, technology, and functionality. Operators are treated to a 6-way captain's chair, complete with intuitive drive-by-wire joystick controls. Touchscreen monitors offer real-time insights into machine functions and operations, ensuring that operators are always in control. Visibility is paramount in land clearing operations, and the Model 5000T delivers on this front with rear-view cameras and reinforced windscreens. To further enhance the operator experience, the cab is fully climate-controlled, equipped with both heating and air conditioning systems. The inclusion of built-in AM/FM radios ensures that operators remain entertained, making long workdays more enjoyable. Safety is a cornerstone of Bandit's design philosophy, and the Model 5000T is no exception. The equipment comes standard with features like rollover bar protection systems, roof escape hatches, fire suppression systems, reverse alarms, and automatic engine shutdown systems. These features underscore Bandit's commitment to ensuring the well-being of operators. Maintenance is a breeze with the Model 5000T. The operator cabs can tilt forward, providing unhindered access to the machine's major components. This design consideration ensures that downtime is minimized, leading to reduced operating costs.